Have you ever wondered what happened after the Big Bang? It wasn't just a burst of light and then darkness. The universe's earliest moments were hot and dense, but that light couldn't travel freely. Imagine being inside a foggy room with a flashlight. Light exists, but the fog scatters it in every direction. That's what the universe was like, a glowing soup of free electrons, protons, and photons. Photons bounced off electrons constantly, preventing any light from traveling far. This dense, bright plasma is why scientists call the early universe opaque. Meanwhile, space itself was expanding and cooling. As the universe cooled, particles slowed down and began to change. Eventually, about 380,000 years after the Big Bang, electrons slowed enough to stick to protons. They formed neutral atoms of hydrogen and helium. Astronomers call this event recombination because electrons and nuclei combined to make atoms for the first time. With electrons no longer free to scatter photons, the fog lifted and the universe suddenly became transparent. This clearing of the cosmic fog allowed light to travel across space for the first time. That freed light is still around today as the cosmic microwave background, the faint afterglow of the Big Bang. You could think of it as a baby picture of our universe. Even though the fog cleared, there were still no stars. This era is called the Cosmic Dark Ages. The universe was transparent, but there were no bright sources of new light, so it remained dark. During these dark ages, gravity worked quietly. Tiny density variations, little ripples in the distribution of matter, began to grow. Matter slowly gathered into clumps, forming clouds of gas that became denser and hotter over hundreds of millions of years. Imagine a quiet night in a vast, dark desert. The wind gently gathers grains of sand into dunes. Similarly, gravity collected gas into ever-growing clouds. When these clouds became massive enough, something remarkable happened. They collapsed under their own gravity and the first stars ignited. These first stars were huge, many times more massive than our sun, and they burned bright and hot. They were the universe's first beacons, marking the end of the Dark Ages and the beginning of the cosmic dawn. Their brilliant light filled the cosmos and began to change the chemistry of the universe. The radiation from those first stars started to rip electrons away from atoms again, a process called reionization. This reionization phase began around a few hundred million years after the Big Bang and continued until roughly 1 billion years after the Big Bang. By the end of this period, most of the hydrogen gas between galaxies was ionized, and the universe was once again transparent to ultraviolet light. As the first stars lived and died, they created heavy elements like carbon, oxygen, and iron. Each generation of stars enriched the universe with more complex atoms. These elements later became the building blocks for planets, life, and everything we see around us. From the ashes of these first giants came the material that would form galaxies and solar systems. The cosmic dawn was a turning point. What began as a uniform fog evolved into a dynamic and structured cosmos. Midway through our story, take a moment to ponder. Before this astonishing sequence of events, could there have been something that existed before the Big Bang? That's a question scientists are still trying to answer, and it's one we'll explore in a future video. Returning to our tale, after the first stars, larger structures began to take shape. Small galaxies merged to form bigger ones, and filaments of gas and dark matter formed the cosmic web. In the centers of many young galaxies, supermassive black holes grew, influencing the evolution of their surroundings. Over billions of years, galaxies collided and evolved into the vast, complex structures we observe today. All the while, the universe continued to expand. The ancient light from recombination, the cosmic microwave background, stretched and cooled, shifting from visible light to microwaves. Today we can still detect this relic radiation with radio telescopes, a faint whisper from the dawn of time. From a dense, glowing fog to the first stars and beyond, the universe's story is one of transformation and growth. It began in a state where light could not travel far and evolved into a cosmos filled with galaxies, stars, and planets. And this story is still unfolding. If you're curious about what might have happened before the Big Bang, or how the universe might end, make sure to subscribe and stay tuned for the next episode.